object-oriented programming using C++ class. In this today's session, we will discuss the pointers in C++. So as we already know that pointer is used to store the address of another variable of that type. That means if we need to store the address of an integer value, we need to define an integer type of pointer. So we can declare the pointer using the asterisk operation, asterisk star symbol. We declare the pointer using star symbol. This symbol is also used. This symbol is also used for dereferencing. That means, what do we mean by dereferencing? Suppose P stores the address of A. Suppose when we declared a variable A, it is initialized with value 10, and suppose the address of this block is 1000. Now the P will contain 1000. So if I write star P, that means we are dereferencing the value. So we also read it like value at P, or value at, what is the value of P? Value at 1000, which is equal to 10, right? Now if we want to store the address of a pointer, then we need to declare a double pointer, int star star q. So if we want to, suppose the address of this location P is 2000, and if we write q is equal to address of P, then let's create a block q which now stores 2000, right? If we want to store the value of double pointer, we need to declare triple pointer like this, r. Now r can store the value of the address of q. The address of q is 3000. R will have the value 3000. So what we have done so far, we have declared, let me write this properly using a code, int main. We have declared P, Q and R, three pointers and a normal variable A, which is equal to 10. And what we are trying to do, P stores the address of A, Q stores the address of P, and R stores the address of Q. So pictorially we can represent it like this. This is suppose A, which contains the value A, value 10, and if the address of this location is 1000 and address of this location is 2000, 3000 and 4000, let's say this is our P, this is our Q, and this is R. So P stores the address of A. So P, the value of P is 1000, value of Q is 2000, and value of R is 3000. Now if we want to print the values, different values of these variables, we can print it like this. Cout A is equal to A, cout B is equal to, sorry, B is equal to P. This will print the address of A. This will print the address of A. Cout Q is equal to Q and R is equal to R. So basically, uh, we are printing the addresses of these locations. Means the first cout will print the value of A, that is 10, and then address of A, address of B, and address of Q. If I write cout value at P, what will this print? This will print 10. If I write value at Q, since this is the double pointer, this will also print 10. What will happen? Value at Q. What is Q? Q is 3000, right? So value at 3000 is 2000. I'm sorry, the Q is 2000 here. So value at 2000 is 1000, and value at 1000 is 10. So here 10 will be printed. Likewise, if I print value at R, so it will also print 10. And we can verify this in our online compiler. Let's open our online compiler and see. Include hello stream using name space std int name. Let's declare three variables. A is equal to 10, P, Q, and R, triple pointer R. And let's assign the address of A to P, address of P to Q, and address of Q to R. Now let's print the values. Cout A is equal to A, 1, 2, 3, 4. So here what we have to print, P is equal to P, Q is equal to Q, and R is equal to R. Now A is is equal to a is equal to, we can say, value at p, and here we can say a is equal to value at q, and a is also equal to value at r. Now turn 0 and let's check the output. Let me check what is the problem here. I'm sorry, here r is not equal to address of r is equal to q. So I think now it should run fine. Okay, so we can see that value of a is equal to 10, then we have entered the address of p. P contains basically the address of a, so this is the address of a, then address of p and address of q, and then we have printed the values of a using different you know dereferencing operator, value at p, value at q, value at r, like this. So I think now you have understood what is the pointer. These are the specific pointer. Now we'll talk about the generic pointer. Let's talk about the generic pointer or void pointer. In this example, you have just saw that to store an integer type of value, we need to define an integer pointer, and to store the floating point of value, we need to store it in the floating point pointer. But we can, if you don't want to do this, we can simply have a void pointer like this. We can declare a void pointer p, which is also known as generic pointer, and this can store the address of any type. This can store the address of any type. This can store the address of any type. For example, let's see one example. Let's take an example directly coded in the online compiler. Remove this code up to here. Uh, let's declare three variables. Float b is equal to 3.123, like this, and character c is equal to, say, capital A. These are our three variables, and declare a generic pointer void p. Now let's store the address of p is equal to address of integer, and try to print the value. See out. Uh, you know, if we print the value of p, it will print the address, simply address. To reference it, a is equal to, how will print the value? Normally, what do we write? Value at p, but this will not work here because this is our generic pointer, and we need to typecast it. We need to typecast it into a specific type, like this, int star. So this is typecasting, and this should run fine now. Similarly, Let me copy paste it 3 times, 2 more times, and this. Now store the address of B, and here we need to typecast it to float B, and here store the value of C, and C is equal to, we need to typecast it to character. So this is our generic pointer, and I think it should work now. Okay, it is working fine. So you can see A is equal to 10, B is equal to 3.123, and C is equal to A. So this proves that a void pointer can store the address of any type of variable, and we can use it like this in our program. Let me just paste this example here. Okay. Now let's talk about the function pointer. Function pointer. See, the way we can store the address of a variable in a pointer, we can also store store the address of a function in a pointer. But here the signature should match. The signature should match. For example, uh, let's declare a function int add int a int b. Suppose this is returning a plus b. Let's create another function subtract int a int b, and this function is returns a minus b. So we can declare a function pointer to store the address of these functions. Int main. Let's declare a function pointer. So function pointer is declared like this. Int, suppose the name of function pointer is fun. Int, this is the declaration of function pointer. So basically we have declared a function pointer fun, and this function pointer can store the address of functions which returns integer type of value, and which has 2 parameters of integer type. So let's first store the address of addition function here, and call this function using the pointer, and directly call it fun 2020. Okay. So basically this should print 20 plus 20, 40. Now fun is equal to, suppose, subtract, and if I again call the fun with some different values like this should return 10. Return 0. So I think now you have understood how we can declare a function pointer and can use it in our program. Let's run this. Let's see this in our online compiler. Remove all this stuff. Int subtract int a int b return a minus b and simply copy paste this. This is our addition and return the addition. In the main method, declare a function fun of type integer. Let's first assign the address of subtract here and call this method. Let's call this function fun. This will invoke the subtract function. So pass some big value, pass values like this, 50 and 10. This will return the 50 minus 10. I'm sorry, there is no need of this value, these brackets. Fun is equal to add. Now again call it. So let's first run it. So you can see uh, this is the output 40 and 60. So when we have assigned the address of subtract function in the fun function, fun pointer, uh, we called this function subtract using the pointer, and it is returning 50 minus 10, and again the fun is pointing towards the add, and this using this call we are getting 50 plus 10 is equal to 60. So I think I have covered. Okay, now we will discuss the dynamic memory allocation in C++. See, we use uh, malloc, calloc for memory allocation in C and C++, and used free to free the memory allocated by them. So how do we allocate, how do we use malloc? Basically, we use malloc like this. And suppose this is our pointer, we need to manually typecast it, malloc and size of int. Basically what it does, it returns a void pointer to the newly created memory space, right? It creates a memory location of this size, whatever size we pass here, and returns a void pointer. It returns a void pointer. So we need to manually typecast it to the specific type. Generally we use structure in data structure. You have seen like this: struct node, p is equal to struct node malloc size of node, like this, right? So this works in this way. We need to explicitly typecast the, the address, because malloc returns a void pointer. It returns a void pointer, and we just discussed that a void pointer need to be specifically typecast to a specific type, right? Now let's discuss the new keyword introduced by the C++. How we use new keyword? We use new keyword like this: int is equal to new int. This is a valid declaration. We can also use this to initialize the value, int 5. So basically what this will do, this will create a new block. It will initialize this block with 5, and whatever is the address of this block, it will return the address to p. Here you can see no need of typecasting. There is no need of explicit typecasting here. Basically, the another advantage of using new is that in malloc, in case of malloc, it does not initialize the value like this. If we use some if we use some object, it can also call the constructor of the object. Like if suppose if we have a class test, suppose we declare a class test like this, and we allocate memory to its object like this: test ob is equal to new test 20. So this will call the constructor also, calls constructor of the class. This is not possible with malloc. This is not possible with malloc. And likewise with malloc, we use free, and with new we use delete. As I have already discussed that new keyword can call the constructor, delete keyword can call the destructor. Okay, new keyword calls the constructor, and delete keyword can call the destructor. Those who don't know what is destructor is defined like this: if there is a class test, destructor will be declared like this, using just like constructor. We use tilde sign to declare the destructor, right? So I think now okay, there's one more important point. We cannot mix, means we cannot use malloc with delete and new with free. That means the memory allocated by malloc will be freed by free, and the memory allocated by new will be freed by delete. So I think now you have understood my point. What is pointer? What is dynamic memory allocation? What is the significance of pointer? How it stores values, etc. So here I have quickly written a code. It's very simple code. Here in this line, I have created a integer type pointer and initialized it some memory location using the integer using the new keyword. And in this line, I have I am allocating memory to the integer value to the integer pointer using malloc. So you can clearly see the difference. Then I have printed the values of p and q, and after our work, we need to deallocate the memory allocated by the dynamic memory allocation operators and functions like new and malloc. So we use free to deallocate the memory allocated by the malloc, that is free q, and delete p. So if I run this code, you can see out. This is the value assigned to the memory location p, and this is the value assigned at the memory location q. So thank you very much. I think now you have understood what is pointer. I will come back with another video of oops very soon. Till then, bye bye. Thank you.